Hello, everybody. Today, what we're going to do is to find the complement of a particular simple graph. When we say complement, actually, it is the opposite of a given graph. So a given graph, G, has vertices and edges. So set of vertices and edges. The complement of this graph, which is simple graph, is given a symbol, which is G bar, is equal to the same set of vertices and opposite edges. All right, so to do this, since our set of vertices is the same, the first step is to draw or label all the points. So here, we're going to put our answer. The first step is to label all the points. We have point A, point B. This is our point C, and this is our point D, right? So that is the first step because there is no change in terms of the vertices. Now, as I mentioned, when I say complement of a graph, that is the opposite of the given graph. Opposite of G, or we call this as not G. Okay, so complement means not. So G bar means not G or complement of G. So this is our G, the original graph. As you can see, our A is adjacent to B or directly connected to B. We have to remove that. We have to do the opposite. There is no connection between A and C. So we have to create this connection, A and C. And A is not adjacent to D either. So we have to create this connection. So A is now connected to D or adjacent to D, right? So you can make a straight line, you can have a curvy, connection. It doesn't matter as long as these points are connected. Okay, so that is for our A. To avoid confusion, we start with the first vertex and then go to the next, right? So our B is adjacent to A as well as to D. There is no direct connection between B and C. So since this is the opposite, we have to draw that. So we have B to C. Okay, so that's it. Let's now proceed to C. C is adjacent to D. It's not adjacent to A and B. So we have to draw that. So we have to draw a line from C to A and C to B. But it's there already. C is connected to A and C is connected to B. Remember, we're talking about simple graph, so we should not draw it again. Right? For D, it is adjacent to B and C. There is no line from D to A, so we have to draw a line from D to A, but it's already drawn previously. So we don't need to draw it again. So this is our answer. This is the graph, which is the opposite of the original graph, right? So to understand better, let's have our second example here. Is that? Okay, the second example contains 5 points, and there are no labels. So to avoid confusion, it is necessary to label the points or the vertices. Okay, so let's label this as 1. This is our 2, 3, 4, and 5 to avoid confusion. And also you can label the edges if you want to, but in complement, there's no need for that. The most important ones are the points because it will be retained. So I'm going to put the answer here. This is our graph G. So the opposite is G complement or G bar. Okay. So the first step, as mentioned a while ago, is to label all the points because we have the same vertices actually. So this is our 1, this is our 2, this is our 3 approximately, this is our 4, and this is our 5. So we are done with labeling all the points. Let's now proceed to the edges. As you can see, 1 is adjacent to 2 and 3. The opposite is 4 and 5 because there is no direct connection between 1 to 4 and 1 to 5. So we have to draw that. Okay, and 1 to 5. As you can see, the lines from 1 to 2 and 1 to 3 are deleted because it's opposite. Here in our first example as well, the line from A to B is deleted, the line from B to D is deleted, and the line from C to D is deleted because it's opposite. So here we have deleted the line from 1 to 2 and 1 to 3. Now let's go to 2. 2 is adjacent to 1, 3, and 4. There is no line from 2 to 5, so we have to create that. Okay, there is no problem to cross another edge. In graph theory, it doesn't mean that there is a point here. Okay, so we can cross this line without establishing a point there. Now for 3 is adjacent to 1, 2, and 5. There is no line from 3 to 4. So we have to create that. Okay. Now let's proceed to number 4.4. It's adjacent to 2 and 5. So the opposite is 4 to 1 and 4 to 3. It's already connected. For 5, it's adjacent to 4 and 3. There is no line from 5 to 2 and 5 to 1. So we have to draw that, and it's there previously. So this is our answer. Actually, this is the opposite of the graph on the left, where we have 5 points, and the G bar or G complement also contains 5 points. Okay, so only the number of edges will change. So that's how to draw the complement of a simple graph. Thank you so much for watching. Until the next time, bye-bye.